Okay, so this is the next question. Which of the following statements are true? There exists a constant C such that log x is less than equal to c times root of x for all x greater than equal to 1. Okay, question number 2. There exists a constant c such that sigma n is equal to, or k is equal to 1 to n, k squared is less than c times n squared for all n greater than equal to 1. Point number 3. There exists a constant c such that modulus of sin x negative x is less than equal to c times modulus of x cubed for all x. So work this out. When we come back, let's see the correct solution. Okay, so let's see the correct choice. Now we have been given log x is less than equal to c times root of x. Now let me show you the graph of log x. This is going to be the graph of log x. The graph of square root of x, that is going to be like this. Okay, and clearly log x grows slower than root of x. So for some c, clearly log of x is going to be less than equal to c times root of x. Okay, so this is true, of course, for x greater than equal to 1. Okay, so the first statement is a true statement. So let us go and check the second one. So the second statement is given as sigma k is equal to 1 to n, k squared is less than equal to c times n squared for n greater than equal to 1. Now consider sigma k is equal to 1 to n of k squared. Now this is equal to n into n positive 1 times 2n positive 1 divided by 6. Now you consider this one, n into n positive 1 times 2n positive 1 divided by 6. Now this is approximately equal to 2n cubed over 6, which is equal to 1 over 3n cubed. So this will actually be growing like n cubed. But what they have given here, you see that? It's less than equal to n squared. Is it going to be true? So sigma k is equal to 1 to n, k squared less than equal to c times n squared is false. Okay, so that's statement 2. Let me go and check for statement 3. Now to check this, not this, we are given modulus of sin x negative x less than equal to c times modulus of x cubed. Now remember, modulus of x cubed is different from modulus of x cubed. Okay, as long as x is positive, there is no difference, but when x is negative, we will have an issue. So that's the reason I'm a little bit particular about writing it like the form that's given in the question. Okay, so now having mentioned that, let me consider, let us consider sin x expansion. What is that? That is x negative x cubed over 3 factorial positive x to the power of 5 over 5 factorial plus etc. Now we consider sin x negative x, which is nothing but x negative x cubed over 3 factorial positive x power 5 over 5 factorial plus negative etc. minus x. So this is going to give me negative x cubed over 3 factorial positive x to the power of 5 over 5 factorial negative, so on it goes. Okay, so if I were to associate this, okay, to a known expansion, so actually in this case we are taking the modulus. Okay, so I have not applied the modulus. Before I could apply the modulus, let me show you this all important information. Now this is a popular inequality result, which is modulus of sin x negative x is less than or equal to modulus of x positive 1. Now when x is large, modulus of sin x negative x is equal to modulus of negative x cubed over 3 factorial plus x to the power of 5 over 5 factorial etc. Okay, this is the modulus that we just got here. Now this one is definitely going to be less than or equal to some c times modulus of x cubed. Okay, based on the fact that modulus of sin x negative x is less than or equal to modulus of x positive 1. Okay, so this means this statement is true. So what are the statements are true so thus far? Let me show you. So statement 1 is true, statement 3 is true. Okay, so that answers this question. Let's move on. Okay.